We are talking about piecewise and greatest integer functions, and we want to be able to graph piecewise functions and write piecewise functions from a graph. Piecewise function is a function that is written using two or more expressions. So down here, we have the function g of x, and this is a function. And right here, we have three expressions. We have y equals negative x minus 2. We have y equals negative 6. And we have y equals negative x plus 4. Now, we have to look at the restrictions of those. So each one of those has the domain, which is restricted, which says you can only use it for these specific x values. In order for the function, you can never have a closed circle and an open circle share the same x values. So it cannot be stacked. So right here, we can see that at negative 4, x equals negative 4, there's a dashed green line. And over here it says negative 4 is included with this function up here that goes to the left with it, which is negative x minus 2. So if we're going to continue this graph, we would intersect the y-axis at negative 2. So that's the graph right there. However, it only exists when x is less than or equal to negative 4. It's equal to negative 6 when it's between negative 4 and 0. So here, we can see that we have an open circle down here. So negative 4 is not included down here, but negative 4 is included up here. And the same thing when we look at negative x plus 4. So here we do have the y-intercept graphed at 0, 4. And here we have a closed dot, and down here we have an open dot. So at no point do we have one input with two different outputs. So this is still a function. And let's take a little bit closer look at what that does mean. So here we have y equals negative x minus 2. So if we turn that on, we can see that this graph continues on and on in both directions, just like we have seen in the past. But now if we restrict the domain, so in this case we restrict the domain, oh, we have an issue there, can't put that in there. If we restrict the domain and we say the domain has to be x is less than or equal to negative 4, we can see that it chops the domain off there, or it chops the graph right there at negative 4. Now, if we can see the points, we come down. Now it says negative 4, the output value would be 2. Now, if we put the other graphs in and with the restricted domain, so this one's y equals negative 6. So we go down here to negative 6, and it says only graph it between negative 4 and 0. But what do we notice about the inequality sign? It says not equal to negative 4, and it says not equal to 0. So it's going to be every single point as we go through here, except it's undefined at negative 4. So as we can see there, it's not included there. It's included at negative 9.96. It's included at 9.7, 9.9. But once we go to negative 4, it becomes undefined, and the same thing going in the other direction. And then we can see the last graph here that we had on the other one. And x equals negative 4 and x equals 0, just to show. And we can see where those graphs line up. So here, negative 4 is included. So the output value at negative 4 is 2. Down here, negative 4 is not included, and 0 is not included. Up here, 0 is included. And so at no point do we have one input having two different outputs. So this is still a function.